This video is the first of a series in which we'll be sharing products that our customers find helpful. Besides standard copper PCBs, here at Omni Circuit Boards, we fabricate superconducting PCBs for researchers. That being said, one common thread we kept hearing in isolation from our quantum computing customers was the need for a junction-safe ohm meter. For quantum computing, the primary nonlinear device is a Josephson junction, equivalent to a transistor in classical computing. When measuring the resistance of a Josephson junction, if you apply more than 300 millivolts, the junction will be destroyed. This means that when there is a need to measure resistances on a quantum computing device, you can't use a standard multimeter because they generally have a compliance voltage of around 7 volts. Since our customers cannot safely use a standard multimeter, they are forced to design do-it-yourself low-compliance devices. Until now. Meet the Ohm Ranger, a low-compliance voltage ohm meter developed and manufactured in the United Kingdom by Altonovus. Here is what Richard, one of Omni's customers, has to say about this junction-safe ohm meter.
We use this meter to measure Josephson junctions. Josephson junctions are a device with very thin insulator between two metals fabricated using standard semiconductor technology. These devices perform at cryogenic temperatures, but some parameters can be measured at room temperature. The main parameter we measure at room temperature is resistance. The problem we had comes because the dielectric is around 1,000th of a micron thick, so very small voltages can destroy the dielectric. That destroys the Josephson junction. This ohm meter limits the voltage that is applied to the device while still giving a good measurement of the resistance. The voltage limit can be set to 200 millivolts or around 400 millivolts. The standard multimeter typically applies 5 volts or more, which is enough voltage to destroy the device you are testing. In a lab where you only have a multimeter, you have to build a protection circuit, and that means the resistance you see on your multimeter is not the true resistance. You have to do a calculation for every measurement to remove the effect of the protection circuit. Also, if you don't follow the protection circuit procedure exactly every time, you can destroy the device. Using the USB port, we were able to automate some of our testing. Once you connect the ohm meter to your system, you can instruct it to do multiple measurements over time, or you can connect to a switch and measure multiple devices. Another mode I like is when measuring small devices under a microscope. When doing measurements under a microscope, it can be difficult to hold the probe tips stably onto very small signal pads, so you don't want to look away to read the meter. This meter can cue you with a beep that your measurement is complete while you keep your focus on holding the probe tips in place. Anyone who works in a lab that measures the resistance of delicate devices would benefit from this tool. This could be MEMS devices or nanoplasmatic devices. These can be devices with very small nanometer-sized gaps between metal electrodes, and a spark from even a half a volt would destroy the device.